We're going to take a look at Chapter 4, Lesson 5, graphing the sine and cosine functions, and we want to get a real good idea of how this translates from our unit circle to a coordinate plane. You can see that I've taken the x and y axis and I've given this a range of 1 to -1. If you think about the unit circle, the greatest value the sine or cosine have is +1 when we are just looking at y equals sine x or y equals cosine x, and that low range value being -1. So I've translated those to our graph. As we're going to graph, we can see the range falls between 1 and -1. Because the sine and cosine go on and on forever, they complete their period in 2 pi, but that circle can go on indefinitely in both directions. So we're just going to look at this, the first part of the sine curve, but understand that it is cyclic and continues on. So let's consider this. If we have the value for the function y equals sine of x, when we allow x to equal 0, then we consider the function the sine of 0, and we go to our 0 angle, and we see that that y value is 0. So what we've done is come up with our first ordered pair, 0, 0. Then we look at the value x being pi halves, or 90, and you can see we've translated the x-axis into radians into one complete cycle from 0 to 2 pi. Well, when x is pi halves, we know that our sine is 1. Again, we're looking at the y coordinate at pi halves. We're going to go all around the circle and just translate these into our table so that we can look at them in the graph. When x is pi, we see the sine of pi to be 0. And when x is 3/2 pi, looking down at 270 degrees, we see that the sine of 3/2 pi is -1. Well, I know that we've all looked at sine and cosine on our graphing calculators, and we understand that to be a curve. We're just going to translate these points. We've got 0, 0. When x is pi, the sine of pi is 1. When x is, pi halves. When x is pi, the sine of pi is 0. At 3/2 pi, the sine is -1. And then at 2 pi back to that same as 0, we see that we've completed one complete period. So we're just going to draw that curve in and see that we come up with our sine curve. Let's take a quick look at the cosine function. In the same way, we understand our range of values going from 1 to -1, and you can see that we have that marked down here on our x and y axis. We're going to take a look at those values. Again, we understand that the cosine on the unit circle is represented by that value x in our ordered pairs. So we're going to translate those at angle 0, pi halves, pi, and 3 pi over 2. We're going to translate those to our table. When x is 0 degrees, the cosine of x, we see a value of 1. Traveling around the circle at pi halves, we see that cosine of pi halves is 0. Pi gives us -1. 3 pi over 2 gives us 0. And then we travel back up to 2 pi 0 degrees, which should be the same as our initial starting value. Well, we think back to the sine curve. We see that that is symmetric about the x-axis, starting at 0, 0. So that should lead you to your conclusion about whether it's odd or even. We're going to see that the cosine function, when x is 0, we start at 1. Our cosine function is going to be symmetric about the y-axis. So at 0, we have 1. At pi halves, we're at 0. At pi, we're at -1. Just taking these values right off the table. 3 pi halves, we're back to 0. And at 2 pi, back to 1 again. So if we can sketch that I know you guys are going to be much better at this than I am. We see a cosine function completing its period within 2 pi, starting at 0, 1, finishing at 0, 1. Now we want to talk about this as a complete cycle or period. And I want to talk to you also about other terms that we're going to be discussing. We have an amplitude, which we find to be from the middle of our graph to its highest point. In this case, we could see that amplitude equals 1. And 1 period is equal to 2 pi. We're going to discuss this more here shortly. So if we look at example 1, it says we're going to consider our parent function y equals sine x, but what we want to do is graph y equals 2 sine x by hand on the interval from negative pi, you can see the graph I've got written out here, to 4 pi. We're going to be doing the same thing and working with this table of values. Well, I've written down the values for x being negative pi through almost 4 pi and the sine values, and simply put 2 sine x just means take the value of sine x and multiply it by 2. So we're going to start plotting some of these values at negative pi. 2 times 0 is still 0. At negative pi halves, we're at negative 2. Negative pi halves, negative 2. And then we bounce back up at 0 to 0. At pi halves, we're at positive 2. And we can see that the cycle is starting to play out. At pi, we're back to 0. And down to negative 2. And up to 0. And up to 2. And we can carry this on, or we can just understand what's going on. We know that this is a cyclic curve, and 2 pi in front of that, 2 sine x, that's going to be our a value that we're going to talk about. F of x is equal to a sine x. They gave it a for a reason. It stands for amplitude. When that doubles, the amplitude of the sine curve doubles, and when we can understand a is greater than 1, we have a stretch of our graph. If a is greater than 0, positive, or less than 1, we should understand we're going to end up with a compression. So we're going to be discussing the transformations, looking at this equation at the top here. It says y is equal to d plus a, we discovered in the previous slide, a sine of bx minus c. A is our amplitude, and it is half the distance between the max and the min. We're going to take a look at b now. The period is given by this equation, 2 pi over b. So let's look at example 2. We see y equals sine of x, that's a pi, Pam, of x halves, by Jordan. We're gonna graph this by hand. We were just given this equation, 2 pi over b, and we can see our b value in this equation is 1/2. We can write this sine of 1/2 x. So let's take that into consideration now as we discover the period. So 2 pi over that value 1/2 indicates 4 pi for the period. Up here you can see we said as b is between 0 and 1, the period becomes greater. Let's take a look at a different one. If we had y equals the sine of 3x, that 3 is our b value, we would again take 2 pi over 3 and see. So on your check it out problems, it says, let's take a look at 45. Y equals 1/4 cosine x. And so what we did in the examples before was to make that table, those x values, it wants to graph this for 2 periods, but we're going to do it for 1 and then extend our graph. And we're going to think about the cosine values, the x values first, 0, pi halves pi, all those quadrant radian measures. And then we're going to take the cosine of that, and we're going to take 1/4 of that value. We can look at that in the table here. When x is 0, the cosine is 1, but 1/4 cosine puts us way down low. Pi halves, we have 0 degrees. 1/4 of that is just 0. We're going to go through this pi, negative 1/4. I'll put that right over there. Back up, 0, you guys understand the cycle of this function cosine x, and we can see that we're just creating this wave action throughout. It's important when you get done, if we went 2 pi or 4 pi or 6 pi, we're going to be ending in the exact same region that we began. So you can see we graph our 1/4 cosine, this 1/4 being our value A, which is our amplitude. Amplitude again is half the distance from high to low. And we can see on our graph 1/4 to 1/4, our entire distance is 1/2, and 1/4 is half of that, defining the amplitude. Let's take a look at problem 47. So we want to consider the amplitude again. Whoopsie, 47, x halves. Let's redo that. It's going to be confusing. X divided by 2. We can rewrite this the cosine of 1/2 x. We know that our amplitude is 2 pi over, hi Dustin, 1/2. If we invert and multiply, we see that our amplitude is 4 pi. So we're going to complete one whole cycle of cosine in 4 pi instead of in 2 pi.